Here are some amazing facts about Golden Tortoise Beetle. Color change. The Golden Tortoise Beetle can change its color from gold to red or orange when disturbed or dead. Camouflage. The color change helps them blend into their environment, providing camouflage. Reflective surface. Their golden appearance is due to a reflective cuticle that scatters light. Size. They are small, typically about 5 to 7 millimeters in length. Family. They belong to the family Chrysomelidae, also known as leaf beetles. Diet. Golden tortoise beetles primarily feed on plants, especially morning glory and sweet potato leaves. Distribution. They are found in North America, particularly in the eastern United States. Life cycle. Their life cycle includes egg, larva, pupa, and adult stages. Eggs. Females lay clusters of eggs on the underside of leaves. Larvae. The larvae are spiny and use their excrement as a shield for protection. Pupation. Pupation occurs on the host plant, and the pupa can also change color. Adult longevity. Adults can live for several months. Predators. Natural predators include birds, spiders, and other insects. Defense mechanism. Besides color change, they can play dead to avoid predation. Host plants. Besides morning glory and sweet potato, they feed on other Convolvulaceae family members. Scientific name. The species name is Charodotylus expunctata. Common names, also known as the gold bug or golden beetle. Seasonal changes. They are more commonly seen during the warmer months. Habitat. They prefer gardens, fields, and areas with abundant host plants. Movement. They are relatively slow-moving beetles. Wing covers. Their elytra wing covers are what give them the tortoise-like appearance. Hibernation. They can overwinter in leaf litter or under bark. Feeding damage. They create small holes or skeletonize leaves, affecting plant health. Pollinators. Although primarily herbivorous, they may contribute to pollination indirectly. Reproduction. They have multiple generations per year in favorable conditions. Mating. Mating occurs on the host plants. Egg incubation. Eggs hatch within a week to 10 days. Larval stage. The larval stage lasts about 2 to 3 weeks. Pupal stage. Pupation lasts about 1 week. Adult emergence. New adults emerge in late spring or early summer. Diurnal. They are mostly active during the day. Chemical defense. They can secrete chemicals as a defense against predators. Pheromones. They use pheromones for communication and mating. Temperature sensitivity. Their color change can be influenced by temperature. Moisture sensitivity. Humidity levels can affect their color as well. Population control. Natural predators help keep their populations in check. Beneficial role. They help control weed growth by feeding on certain plants. Insecticides. They are susceptible to common garden insecticides. Research interest. Scientists study their color-changing ability for insights into materials science. Elytra structure. The microscopic structure of their elytra is responsible for their iridescence. Antennae. They have short, clubbed antennae used for sensing their environment. Social behavior. They are generally solitary but can be found in groups during mating. Flight. They can fly but do so infrequently. Sound. They are silent insects and do not produce any noticeable sounds. Interaction with humans. Generally considered harmless to humans. Pest status. Can be a minor pest in gardens but rarely causes significant damage. Conservation status. Not currently considered endangered or threatened. Variability. There is some color variation among individuals. Etymology. The name sexpunctata refers to the 6 spots that are sometimes visible on their elytra. Ancient history. Fossil records of related beetles date back millions of years. Lifespan. Total lifespan from egg to adult death is typically a few months. Behavioral study. Their behavior is a subject of interest in entomological studies. Color stability. The gold color is more stable in living beetles compared to dead ones. Artificial habitats. They can be kept in captivity for educational purposes. Interaction with ecosystem. Play a role in the ecological balance by feeding on plant matter. Impact of climate change. Climate variations can affect their distribution and life cycle. Observation. Easy to observe in gardens and can be used for educational purposes. Literature. Mentioned in various entomology and biology texts. Symbolism. Sometimes used in art and literature as symbols of change or transformation. Bio-inspiration. Their structural coloration inspires designs in materials science and engineering. Microhabitat. Prefer the underside of leaves where they lay eggs and feed. Molding. Undergo several molds as they grow from larvae to adults. Adaptability. Can adapt to different environmental conditions within their range. Evolutionary adaptation. Their color-changing ability is an evolutionary adaptation for survival.